Hello, today we'll be talking about calorimetry. Calorimetry is used to determine the amount of heat absorbed or released in a chemical reaction. This change in heat lets us know whether the reaction was exothermic, meaning it released heat to the surroundings, or endothermic, meaning it absorbed heat from the surroundings. When discussing surroundings and systems, it is important to note that the system refers to the chemical reaction and the surroundings relates to the outside factors such as solutions, air, etc. Calorimetry works because by using a substance that is well known, such as water, as the surroundings, it is possible to discover the transfer of energy that took place in a reaction. By using a coffee cup calorimeter, which we have done a couple times this semester, we can discover the overall enthalpy change in an aqueous solution. However, there are some limitations to this method. This method can only be used in an aqueous environment and at low temperature reactions or state changes. The styrofoam cups used in a coffee cup calorimetry ensure that the chemical reaction taking place occurs at constant pressure and prevents the loss of energy. The use of water is very important in this experiment because by using the specific heat of water, we can discover the energy that was used to raise or lower the temperature of water in the calorimeter. This is possible because the constant pressure enclosed system provided by the calorimeter allows us to assume the temperature changes of the water was a direct result of the chemical reaction taking place. Now, just as a reminder, in case you have forgotten, specific heat is the amount of heat in joules needed to increase the temperature of a substance by 1 degree Celsius. For water, that value is 4.184 joules of energy needed to raise 1 gram of water by 1 degree Celsius. To perform a coffee cup calorimetry yourself, you're going to need to determine the mass and volume of the reaction mixture and measure the change in temperature of the reaction by using a thermometer or temperature probe. Once you have gathered these values, you can use the equation Q equals mc delta T in order to determine the heat lost or gained by the surroundings. Remember when performing your calculations to take into consideration the sign of the heat or your Q value. If the temperature of the water increased, this would mean that the surroundings gained heat and the sign of Q surroundings would be positive, whereas the sign of Q system would be negative and vice versa. One tip for more accurate results is to remember to quickly put the lid back on top of the coffee cup after placing all of your reactants into the calorimeter. In addition, after you finish your experiment, remember to dispose of the chemical substances you dealt with appropriately, and remember to always wear your proper PPE when dealing with chemical substance in order to complete this experiment as safely as possible. Hope this cleared up any confusion you guys may have had when dealing with calorimetry, and enjoy this calorimetry pun.